Hello class, good morning. How are you today? Okay, we continue with our lesson today. Direct variation, and we'll look at example 5 to 8 in the textbook. Yeah? Okay, let's go. Okay, let's see example 5. The extension of a spring x cm varies directly as, this is the symbol, the mass of the load W, yeah, hanging on the string. So first we have to write the variation relation. Yeah? X varies directly as the mass of the load, that is W. Okay, it is given the extension of the spring is 3 cm. That means extension is x, 3 cm, and the load of 200 gram. That means the W is 200. Is hung on the string. Express x in a term of W. That means x equals to something W. Okay, your something here is actually your K. Okay. Okay, how to do this? Okay, this is your variation relation. It's a symbol form, but you have to change it into equation form. Yeah. So x equal, once you put the equal sign, you must write the K and then you write back the W. Yeah? That means K times W. Then, of course, you have to figure out what is your K, right? Before you express it in a x in a term of W. So your job now is to find what is K. How to find K? Here, it's given your x is 3, your W is 200. So you just substitute. Yeah, you just substitute inside here. So this one is 3, x is 3, K is the one that you want to find, and then times 200. K is 3 over 200. K is actually 0.015. Now you have found your K, then now you can write x in a term of W. So x equal, your K here is 0.015 times W. So you have answered the question. Express x in a term of W. So very simple, right? Example 6. It is given y varies directly as x. If y equals 0.14 and x equals 0.2, calculate the value of y when x is 5. Okay, this time you are asked to find one of the values in the variable. So what you do is, this is very important part. This is the information that you have to write into y varies directly as x, and you change into equation form y equal kx, and then your y and your x will help you find your k. You just substitute your y 0.14 equal k times 0.2, your x. So k will be 0.14 divided by 0.2. You will get your k 0.7. Okay, with this 0.7, now you complete the equation. Y equal 0.7 x. So with this, you can find your y. So y will be 0.7. You substitute your 5. Your x is 5. So you'll get your y is 0.87 sorry, your y will be 3.5. Yeah, 3.5. This is the answer. Okay, so now we go to B. For B, find the value of x when y is 0.875. So now you don't have any more, you already got your equation. Where's your equation? This one. So you write back the equation 0.7x. So now you just, you want to find your x, you just substitute your y inside here, right? So 0.875 equals 0.7x. So x is 0.875 divided by 0.7. X is 1.25. So you have answered your x. What is your x? This one. What is your y? This one. Okay, done. Okay, example 7. The area LCM square of a semicircle varies directly as, varies directly as the square. Okay, the square of its diameter. Okay, so how do you write that? L, okay, varies directly as the square. This is very important, the square of its diameter. You cannot just write D, but this one, the square. So you have to write the square. Yeah. It is given that the area of the semicircle is 3.08. So this is the one, the area of the semicircle, 3.08. When the diameter is 2.8, diameter 2.8, the area is 3.08. So the question is, calculate the value of D, this one, your D, when your L is 19.25 cm square. So what do? First is this one, you have done this. Second one, write into equation form. L equal K D square, K times D square. And then use the information given here. This is your L, this is your D. So you substitute 3.08 equal K times your D is 2.8 square. So your K is 3.08 divided by 2.8 square. You will get your K equal 11 over 28. Yeah, this one is in a fraction form. So you write it back to this equation. L equal to 11 over 28 D square. So once you get this equation, it's easier for you now to calculate the value of D when L is 19.25. Yeah? So you just substitute L is 19.25 equal 11 over 28 D square. So your D is your D square is, you get 49. Use your calculator. And your D is, you square root your 49. So what you get? Your D is 7 cm. So this is the answer. Okay. Okay, let's see example 8. The period of oscillation of A seconds of a simple pendulum varies directly as the square the square root of length of its string p cm. Okay, you have to write it like this in the symbol form, yeah. So your A varies directly as square root, yeah, square root of length. So square root of length is p. Okay, we read some more for the information. It is given that 9 cm string of a simple pendulum oscillates for 1.2 seconds. So what is this? 9 cm is what? 9 cm is your P, 1.2 is your A. So how do you know that? If you get confused, you just look at the unit. cm is your P, and then second is your A. Okay, and then the last one, the question is calculate the period of oscillation in seconds. That means your A, what is your A? If the length of the string is 25, that means your P is 25. Okay, so what do? You got this already, so you change this into equation form K times square root of P, and then you just substitute your A and your P inside here. Your A is 1.2 equal K, your P is 9, so K equal 1.2 divided by square root of 9. So you will get K is 0.4. Now you just substitute your K in the equation. You will get A equal 0.4 square root of P. So this equation is very important for you to find what is your A. Okay, so you write back this one. So your P is 25, so A equals 0.4, this one 25, you'll get, answer is, use calculator, you get 2 seconds. So this is the answer. So as simple as that one. What is important is you have to read the questions carefully. You have to write these two important information first, yeah. Find your K, and then you substitute back, and then when you get your equation, it will help you to find the value of one of the variables. Okay, thank you very much.